All right, probability, aka how to bamboozle small children. In this problem, we've got a carnival booth, and the folks running this booth are planning on making money. But to someone who comes along, they might think, hey, this is a chance where I can make some money if I get lucky, right? It's a game of chance. And I'm wondering, what is the expected profit margin of the people running this coin booth? In other words, how much do the people who set it up plan to make? So that word that I used, expected, is key here. I'm going to set up the expected value from the point of view of the people running the booth for each of these different coin flips. Okay, we need a little more room here. Let's move this over. Okay, there's my expected value. So I want the expected value of a quarter flip, of a dime flip, and of a nickel flip. And if you read the rules for this problem, you understand that someone who's playing the game gets 3 coins to flip. They pay $1 and they flip these 3 coins. So if a nickel turns up heads, it's worth nothing. But if it turns up tails, the person flipping the coin has to pay. So what's the expected value of that? Well, it's going to be 50% chance of heads. I'm assuming these are fair coins. Okay, we should point that out. 50% chance of 10 cents and a 50% chance of 0 cents, right? There's your win-loss. You might win 10 cents, you might lose nothing, right? You might just get a 0. But your expected value of this, let me bring this somewhere else where I'm just talking through this. Your expected value of this one is just the result of running this calculation. So that's going to be, well, 0.5 times this is 0.05 plus 0 equals 0.05. So I would say that's my expected value. Now another way to do this, and this will save us a little bit of time in making equations, is just to say my expected value is equal to the winnings plus the losings, and take the average, because half the time it'll be one, half the time it'll be the other. This is going to give us the same result, 0.05. So I'm going to set up that equation for each one of these quarter, nickel, and dimes up above. The expected value of the nickel is going to be negative 10 cents. I'll just keep using these numbers with the negatives. 0.10. Okay, so that's going to be negative 0.05. Okay. The expected value of the dime. Well, I typoed this one, hold on. The expected value of the dime is half, or in other words, the average of 0.1 minus 0.1, right? There's your winnings, there's your losings. So that's going to be 0. In other words, you flip this dime 100 times, 50 times it's heads, 50 times it's tails, you come out nowhere, right? You don't make any money. But the quarter has very, very different outcomes. With the quarter, you're going to be, let's see, what did I put first? I put winnings first. Okay, so you're going to be winning $1.50 if it's heads. But you're going to be losing, well, again, it's 0 if it's tails. So someone who doesn't understand probability comes to this thinking, well, worst case scenario, I lost nothing, right? I don't have to pay anything if it's tails. Great, so that's going to be 75 cents. Okay, that's your expected winnings for the quarter. Oh my gosh, move over. 0.75. All right, so let's add this up. What are your expectations for this game? Well, if I'm playing this game, I expect that at every coin flip, I make 70 cents. Cool, but I just paid $1, right? It costs $1 to play this game. It's great if you flip a heads on the quarter, you make 50 cents. But on average, you're not going to flip a heads on the quarter. You're going to flip a tails half the time. So on average, you're going to make 70 cents in a single play of this game, which costs you $1. So that means the average game goes like following. This pays the booth 30 cents. because you won 70 cents, it cost you $1 to play. Now, bear in mind, this is average. There are going to be some games that are big wins, some games that are big losses, but overall, this is what it turns out to be. And if you have 320 of these games, well, then the total profit is equal to 320 times your expected profit per game. And those lucky games and those unlucky games, they'll all average out in the end, and you're going to land somewhere in the neighborhood of $96. Maybe you get $100, maybe you get $90, who knows. But this is the expectation value.